Here we go. Last part of chapter 12.2 is cylinders. Yesterday we did our rectangular prisms, triangular prisms. Okay, we worked with all prisms yesterday. Thanks, buddy. Today we're moving on to cylinders. Okay, but before we do this, we have to understand with a cylinder, what shape is our base? They're circles now. Okay, that's the only thing that makes it really different. So in a circle, you're going to have a radius. Okay, a cylinder is going to have a height. Okay, because otherwise you're not going to be able to solve this. Okay, and like Carson just told us, our bases are circles, right? Okay. Now, what we're doing today is we're only working with right cylinders. So just like yesterday, we're not going to work with cylinders that look like this yet. Okay, we will work with oblique cylinders here in a section or two, but not right now. Okay, everything that we do has to be a right cylinder. Okay. So, the first example we are going to look at is a cylinder with a radius of 4 meters and a height of 8 meters. We have to take this and try to find the surface area. Yes. Okay, now we are going to have to do the exact same thing we did yesterday. Except the difference is I have circles as bases, right? Okay, so we are still going to use the fact that the surface area equals 2 times the area of the base plus what? The perimeter of the base times the height. Okay, we're still using that exact same thing. Now, the catch is it does change a little bit because the area of my base is going to be more specific. It's going to be pi r squared. The perimeter of my base is actually what in a circle? Circumference. So the perimeter of the base is actually going to be 2 pi r. Okay, so that actually takes us to our theorem for the day. Okay, surface area of a right cylinder okay, they just change it up just a little bit. They, instead of giving you 2b plus pH, they say surface area is equal to 2b plus ch. What's c? Yeah, it's your circumference. Okay. So I have 2b plus ch. Now, some people in the last couple classes wanted to write it out a little bit more specific, which is, I'm just fine with that. That's okay. They said it's 2 pi r for area of base squared plus, instead of circumference they wrote 2 pi r times h. Is it still the same thing? Yes, it's still the exact same thing. Okay, so if you want to use that one, that's fine as well. It's just a little bit more specific for you. Okay, so let's go ahead, use that, and let's go up here and finish solving this. So when I plug in, I have surface area equals 2 times, now I have to find the area of my base. Taylor Arnett, what's the area of my base? That's a 4, sorry. 16 pi. plus Taylor Hart, what's my circumference or my perimeter of my base? Close. 8. How about 8 pi? Right? Because it's 2 pi r. So 2 times the radius is 8, but you got to multiply that by pi still. And my height, everybody, is 8. Royal, what do I get here? 32 pi plus 64 pi. Are those like terms? Yes. Yeah, they both only have a pi, so I can combine them for a total of 96 pi label meters squared. Good. Okay. The other two classes thought this was actually easier because you don't have to worry about, is the base a triangle? Is the base a pentagon? Is the base a hexagon? The base is always going to be a circle. Okay, so they thought this was a little bit easier than your prisms. Think so? Okay. Since you think it's a little bit easier, let's do one that's a little bit harder. Not a lot harder, just a little. I think you guys can still handle this. Okay, they tell us that the radius of this cylinder is 9.5 inches. And they tell me the surface area is 925.2 inches squared. We want to know what's the height. Jacob, you think you can set that up? Okay. Not quite. Well, it's 2 times the area of the base, right? How do you find the area of the circle? Yep. It is pi r squared, so you need to square that, right? Good. Now you have 19 pi times h. Does everybody understand what he did to set this up? Okay, he knew that they gave us surface area, and he recognized that it was a cylinder, so he went ahead and used the formula for surface area of a cylinder, except he already knew what the left side was, right? He already knew the answer. So his variable was actually clear over here at the height. Seth, now what would you do? Okay, so you're going to... Yeah, and it's kind of distribute, I guess, but basically you're just multiplying, right? I almost said distribute, too. So you have 180.5 pi. Did I do that right? Okay. Plus 19 pi h. Carson, now what?
Now you're going to subtract 180.5.
Good. I had one person in each class so far tell me to divide by 19 pi. I don't want to do that yet, right? Am I going to have to do that? Yeah, but not yet. I got to get rid of this addition subtraction first. So I'm going to subtract 180.5 pi. Subtract 180.5 pi. Now that's not a pi, right? And that is. So can I leave it in terms of pi anymore? No. You're just going to have to go ahead and get that as a decimal. So you have 925.2 minus 180.5 pi, and I get what? 358.14. I'm going to go 143. because I know we're not done using that number. So I'm going to try not to round it too much. Does that make sense? Hey, I'm going to go an extra decimal place so I can be more exact with the answer. Equals, what's left over there? 19 pi h. Now I can do what? Now I can divide by 19 pi, right? Now you have to be careful here. Why? You got this is that scenario where you have to make sure you have parentheses there. So you have 3. Oops. Divided by 19 pi, and I get my height to equal what? 6. Amanda, what's my label? Why is it not inches squared? Yeah, we found the height, not the surface area. Good. Okay, so what I'm getting at here is there's for sure 3 problems, maybe more, I can't remember, that you're going to come across today where you have to work this backwards and find something else besides the surface area. They're going to give you the surface area. You're going to have to work it backwards. Did you not get that answer, Taylor? Did you put 19 pi in parentheses? You didn't put 19 pi in parentheses. Got it now? Okay. The other thing, be careful here, please. Can you add these 2 things together? No, you cannot add them. They're not like terms. That has a pi, that does not. This is not 8 pi. This is 6 pi plus 2. Okay, which is going to be like almost 20 plus 2. Okay, big difference here. Can you multiply these together? Yes. You can multiply those. Okay, so you can multiply things with unlike terms or that are not like terms, but you cannot add them. Okay, if I had 6x times 2, I'd have 12x, right? But if I had 6x plus 2, I'd just have 6x plus 2. Everybody understand what I'm saying? Okay, so just be careful. You're going to have a couple scenarios like that. This works for radicals too. Same thing. If you had 6 square roots of 3 plus 2, it'd just be 2 plus 6 square roots of 3. But if you had 2 times 6 square roots of 3, it'd be 12 square roots of 3. Okay? So just be aware of that. I know we've went over that and we've talked about it, but just a little refresher there. Okay, your assignment is here.